Today I'm going to speak to you about SST's range of optical liquid level sensors and specifically about chemical compatibility. Our plastic sensors are made of, we have two plastics, we have polysulfone and Trogamid, and these are both high-grade engineering plastics, and typically when one plastic is not suitable for a chemical, the other one will be, and if neither are suitable, then you can move to our higher specification glass tip sensors, which are impervious to just about anything you can throw at them. We've done a bunch of testing in the last week just to give you an idea of the kind of things you're looking out for when you do a chemical compatibility test, but it's something you really have to do unless you're confident that it's not going to be a problem. For example, you're using a sensor in water or in one of the chemicals which we mentioned in our application notes, which is available on our website. If you've chosen a polysulfone sensor and the chemical you're going to use, the concentration you're going to use it in is on the data sheet, then you can be pretty confident it's going to work. That said, it's important to test the sensors thoroughly before you decide to use them in your application or in your product in any significant volumes. So for example, you might find the chemical was certainly okay at room temperature, but if you maybe tested the sensor in that chemical at the top end of the temperature range where everything becomes more aggressive and the chemical will have more of an effect on the sensor, you might find there's then a problem. So it's really important to test your sensors thoroughly. It explains that in our application note. It says that you should test the sensors typically for about 3 weeks. You want to immerse the sensor in the liquid. You want to immerse it in the liquid and have the liquid at the temperature, typical maximum operating temperature that would be present in your product or in your application. And that gives the chemical, whatever it may be, the best chance of damaging the sensor housing, the plastic, if that's going to be the case. If the sensor passes that test with no problems, then great, you can go ahead and use the sensor. Things to look out for would be cracking, crumbling, crazing, melting, deformation, and swelling. And we've got some sensors that we've prepared earlier. So one of our chemists has very kindly dropped a bunch of sensors into various chemicals. I think I can pronounce most of them. And he has, they've only been there for about 3 days actually, and he has chosen some quite aggressive chemicals. We really did that so that we could quickly produce some examples of what failed sensor would look like, so you know what to look out for. So over here I've got sensors which have got a label on them saying control, so they've not been subjected to anything. A bunch of different ones with, these are customer specials, in fact, these particular ones. These are made of Trogamid, so Trogamid is the kind of yellowy clear coloured plastic. Polysulfone is the very dark, it's actually a very dark purple, although it's black plastic. These are the controls. You can see they're nice and shiny, tips are smooth, the epoxy is nice and smooth at the back. When you do a liquid compatibility test, you probably don't want to get the liquid on the back because in the real world, it's really only the front of the sensor that's in the fluid of interest. The back is usually in fresh air. But if there's a concern about the chemical that you're using the sensor and getting to the back of the sensor, you should also test that. But really the epoxy is not designed to be impervious to chemicals. It's really just there to keep the electronics in place and to keep moisture out of the product and out of the housing. But certainly when a product starts life, it should be nice and clean and smooth and not have any bulges or deformations. So let's look at the first test. The first test he did was in acetic acid, which is, vinegar. The polysulfone housing, you can see, looks absolutely pristine. It's nice and shiny. It looks just like the control one at the front. There's no marks, there's no softness, it's not tacky. But the epoxy at the back has been affected. Again, that's not something you necessarily need to worry about. But in our test, just to make things easy, we just dropped them into beakers full of the chemical, so the chemical was able to attack the back of the sensor as well. So depending on your application, I would still use the polysulfone in acetic acid. The Trogamid, however, has not fared so well. There's also some problems happening with epoxy. Again, that's not necessarily relevant. But if you look here, we can see that the tip is no longer nice and shiny. It's kind of pitted. In fact, it's actually soft. I can dig my nail into it. The threads are all just a bit rough looking. It's definitely been negatively affected by the acetic acid. So, if you're going to have a vinegar sensor, use polysulfone. Acetone, we'll start with the Trogamid. Well, acetone's done something very strange to the tip. It's left a kind of white, milky coloured deposit on it, and it's reasonably smooth, but it's definitely had some kind of effect. And it's had a very strong effect in the polysulfone. You can see it's discoloured it, it's gone a milky colour as well, and it's really made the polysulfone become rough. That's definitely been bad for the sensor. Dichloromethane. Wow. Okay, so it's absolutely destroyed both sensors. I think it's fair to say you really shouldn't use our sensors in dichloromethane. You can probably use the glass ones, they'd probably be fine, I suspect. Ethanol, which is that's just pure alcohol, that seems to have done no damage whatsoever to any part of this Trogamid sensor, and the polysulfone also looks fine. Ethyl acetate, or ethyl acetate perhaps, I'm not a chemist. Again, the tip of the Trogamid sensor looks nice and shiny, looks perfectly untouched, threads look okay, it looks like it's been absolutely fine, but the polysulfone has really started to melt. What used to be a nice, sharp, pointed cone is a bulging, lumpy, deformed, rounded, it's now got a rounded tip on the back of the sensor. The whole thing's just, yeah, it's not in very good shape. So, if you want to use ethyl acetate, it looks like Trogamid would be your one. Although, having said that, we only tested them for a few days and we didn't test them at very high temperature, so you would have to do a complete and thorough test. Ethylene glycol, so that's antifreeze that gets used in your car. So our sensors are often used in the header tanks of coolant level tanks in vehicles. So ethylene glycol would be an example of the chemicals to which they were subjected, usually a 50-50 mix with water. And both Trogamid and polysulfone look absolutely perfect, like the day they were made, no problems. IPA, isopropyl alcohol, no effect on the polysulfone, and no effect on the Trogamid either. And finally, methanol, the other kind of alcohol, but the one you really don't want to drink, is polysulfone looks absolutely fine, and so does methanol. So there you go. So there's a range of sensors. I have also personally tested these sensors in Guinness, whiskey, and milk and apple juice in the past, but that wasn't the most scientific of tests. That's what you need to do if you want to do chemical compatibility tests. As I said, 3 weeks, maximum operating temperature, and you're taking the sensors out after that. You might know after a couple of hours that it's not going to work. The dichloromethane destroyed these in a few hours, but maximum 3 weeks. And if the sensor comes out and it looks pretty much the way it looked when it went in, it's a good idea to keep a control back, keep a reference sensor to compare it with. Then if everything looks okay, and of course if the sensor still functions electronically, and I'm sure it will if it looks okay, then you're good to go and you should be able to use the sensors in that application. So thank you very much.